Hello developers, welcome to day 11 of the 30 days of JavaScript challenge. Today offers another chance for us to take on challenges and deepen our understanding of JavaScript concepts. Let's dive in and make the most out of this learning journey. Today's challenge says, given a function fn, return a memoized version of that function. And it explains what a memoized function is, and a memoized function is a function that will never be called twice with the same inputs. Instead, it will return a cached value. And there are some functions here, like this sum function accepts two integers and returns the sum of those integers. Then this fib function accepts a single integer and returns the nth value of that integer in the Fibonacci series. Then there's this factorial function that accepts an integer and returns the factorial of that integer. So if you go to the examples, example 1 says, if the function is sum, that means it returns the sum of integers. And if you call this sum function with the arguments 2 and 2, it will return 4, because 4 is the sum of 2 and you call it the second time with 2 and 2, it will return 4. But this time it will not call the function. It will get this value from the cached value. And that is what a memoized function does. So this is the first example. That's why I say 4, 4. Then if you log the count, it will be 1, because the function will only be called once. Example 2, it's about the factorial. So if you pass 2, it will return 2, because 2 factorial is 2. If you pass 3, it will return 6, because that is what is 3 factorial. And if you pass 2 again, it will return 2, but this time it will not call the factorial function, but it will get this value from the cached value, because you already called 2 before. The last example is this one for Fibonacci. If you call it with 5, it will return 8, because the fifth number in the Fibonacci series is 8. And that is how this memoized function should work. So let us learn some key concepts first before solving this challenge. The first key concept that we learn is the concept of pure functions. And a pure function is a function that when given same inputs will return the same output. Let's look at an example. Let's say I have a function called double that doubles a number. So it takes a number, let's say n, then it returns that number that times 2, that is doubling the number. So it will return n times 2, like that. So if I call this double function, let me log it. So if I log this double function, double, and if I call it with the value 5, it will return 10. And if I call it with 5 again, it will also return 10. And this double is a pure function, because given the same input, that is 5, it will always return the same output, 10. And that is what makes this double a pure function. Let us look at an example of an impure function. An impure function is a function that returns different outputs with the same input. Like let's say I have a function, I'll call it multiply, that takes a number, let's say it takes a number n also, then returns n times a random number. Like I'll use this math.random to get any random number. And I believe by now we already know about the math.random, we already discussed about it. So this multiply, if I call multiply, let me just remove this log and put it down here. But this time I'll call multiply, not double. So if I call multiply with the value 5, I'll call it twice. And let us run this code and see. Take note that I called multiply with the same input, that is 5. But in the console, in the terminal, it will give me different results. You can see the first result is 0.5. The second result is 3.5. You can see it gave me different results, but I have the same input. So this other function, multiply, is not a pure function, because with the same input, it gives me different results. So that is how a pure function is. It gives out the same results when given the same input, like that. The other key concept that we learn is JSON.stringify. So this JSON.stringify, it's a built-in function in JavaScript that converts an object or an array into a string. Let's say just convert any value into a string. It can also take numbers. So let's say I have an array. Let's have my array here. It will be an array of numbers like that. Then I want this array to be a string. I can just pass it in this JSON.stringify. So I can say JSON.stringify. Then I pass my array there. So this one will be a string. So I can just, let me just log this one. Maybe I can log its type. So I'll say type of, not type error, type of. And if I run this code, you can see it says string. So that is the work of JSON.stringify. It converts a value into a string. And there is this other one called JSON.parse. JSON.parse. It's just the opposite of that stringify. It takes a string and it converts it into a JavaScript value. For example, let's say I have a string. Let me call it, I don't have a name. Let's say name. Then let's say it's a string of an array like that. So this is a string, not an array. This is a string. So if I pass it in JSON.parse, if I JSON.parse, then I pass, let me call this is a bad name, don't know, I'm poor in naming. Let me call it array to means an array that is a string, but it's a string. So if I pass this there, then I log this one. Then I'll log the type because only interested the type. So I'll say type of that. Then let me comment this one so that does not disturb us in the console. And if I run this code, you'll see here it will say object, because we talked about how arrays can be represented as an object. So this will be converted into an object. So that is how the JSON.stringify and JSON.parse work. To learn more about this stringify and parse, you can visit our Learn JavaScript course that I'll put in the video description. The next concept we'll talk about is memoization, and this is the main topic of today. So memoization is a technique to optimize the performance of functions by caching the results and reusing them when the same input occurs again. For example, you have this function that we had before called double, and we saw how this function works. So if you put a value like 5, it will return 5 times 2, that is 10. So if you call it again with 5, instead of calling this function again, we can store the results somewhere. And when you call it the same value, we can check that it's like a table. You can check it there. And if it's there, we'll just return the value instead of calling this function. So you can reduce the number of calls to this function. And that will only happen if the function is a pure function. Because you have seen that if it's impure, the output is different with the same input. So this memoization only works for pure functions alone. So I can create another function outside here. This is a decorator function. I'll call it memoize. And I'll use the anonymous function syntax like that. And this function will take another function as input and return a function as output. So it's a high order function like that. And this is the same syntax I've been using since the first day. So if you're following this course, you know about this. It's called the decorator design pattern. So this memoize is just a decorator. So this function, it takes a function, then this inner function can take any value, say let's say x. Then you can return the value of that outside function, fn, called with x. So let me just show you what I've done. So I've just called this, and here I'm using this memoize as a decorator function. So I've just done almost nothing. So let me just log this so that you can see what I've done first. So you know that this, I can call memoize with the function. So in this case, I'll call it with double, like that, double. And we all know that this one will return a function. So I can either call it here or save it to a variable, then call that variable. And this is what we have been doing since the first day. We have been assigning this function to a variable because you know how to treat function as first class citizen. We already talked about that. So I'll assign this into a function called my function, like that. Then I can call this function, let me just log it. I can call this my function, I missed the spelling. I can call this my function with any value, for example, 5. So in this case, if I call my function with 5, this memoized will be passed with double. Then I'll be just be calling this function with the value of 5. So I expect it to return 10. I'm just showing you that what I've done, but you have not started about memoization. So this outside function is just a decorator function. You want to modify this function, or you want to modify any function passed here. That's what this outside function does. So what you want to do with this outside function, you want every time this function is called, we want to cache the value so that when it's called with the same input, we don't call this function, it just return the value. So I'll create a variable here. We saw how this is called a member variable. So I'll call it cache, like that. And to store those values, you can either use arrays or objects. So let me start with arrays. So it will start as an empty array. Then we all know that this, instead of returning it, you can store it to a variable first. So I can create a variable here. I can call it result. Then I return results, like that. So that's how the function was. I didn't change anything, just the arrangement. So we want every time this inner function is called, before we return the results, we want to store the results here into this array. So we can say before we return it, we want to store cache index x to be results, like that. So when I call this double with the number of 5, cache index 5 will be result, and the result of that case will be 10. So the next time I call it, so I can create an if statement here. I can say if the value of cache index x is not, it's truthy. We said if it's truthy means it's there, or I can say it's not equal to null. And let's say it's not equal to null, because you know that if the index does not have a value, it will be null. So you can say if cache index x is not equal to null, return the value of, return that value. So to access the value in array, use the square bracket syntax. So yeah, so this will I've made this function to be memoized. So every time I call this function, it will first check if that variable has been called before by this if statement. If it has been called before, save the result. So the first time I call this function with 5, it will be passed here, it will be called with 5. Then since it's not there, this results will be worked out, then 10. Then I'll store cache index 5 to be results. So this will be something like this. So it will be cache index 5 will be equal to 10. So the next time if I call this function again, so if I duplicate this line of code, if I call it again with the same value 5, it will run and it will check if cache index 5 is there. So if it's there, if it is there, it will not equal to null. So it will return 10. That means that this function won't be called, and the results will be got from this cached array. So if I run this code, I expect it to give me 10 and 10, but this second 10 will be from this cached. So actually let me create a variable here to prove that the function won't be called. So I'll create a variable, I'll call it call count, and it will start with 0. So this variable will keep track of the number of calls this function is called. So every time this function is called and to increase, you can see this function is called in line 10. So every time that function is called and to increase the value of call count. So I'll say call count plus. Then also let me log the number. Let me also log the call count. Let me log the call count, like that. So I expect this call count to be 1, because the first time I call this function, it will run. The first time I call it with 5, it will call this function. Where is it? It will call this function. But the second time I call it, it should not call this function, but it should get the value from the cached array. Actually, this one should be undefined here, not null. It should be undefined here. Or you can just get rid of all of it and use the truth value, because both null and undefined are false. So you can just leave it like that. So let me run this code. Fingers crossed. You can see in the console it says 10, then 1. This 10 is the value of that first function call, that I called it with 5, it gave me 10. This other 5, it gave me 10, but you can see the call count is 1. That means that this function was called once, meaning this other call to the function did not actually call this function, but got the results from the cached value. And that is how memoization works. This is just a simple example, but memoization is highly used in especially dynamic programming, where they're called expensive function, which take a lot of time to process. Like something like, let's say, getting the factorial of a huge number. It will take a lot of time. So you can store the results to a variable, like here we used an array. Then every time that same input is called, instead of running the function to calculate the factorial, you can just get the value from that variable. For objects, it's just the same thing. So instead of storing in an array, you can store in an object like this. So I'll just convert that into an object. And for object, we need a key. So I'll create a key here. So I'll say const, I can call it key, is equals to. So you know that in objects, the key mostly is a string. So I can use this one as a key, this value of x, in this case 5. I can use 5 as the key, and I'll first convert it into a string. So I can say something like JSON.stringify, the one that we learned, then I can pass x. So my key will be that. So here, instead of storing the results to x, now I can store as a key like that. I know by now we know how to use the object, so I can store catch key is equals to result. Then here, instead of checking for catch x, I'll check for catch key, and also here I'll return catch key like that, and everything else remains the same. So here in this, we'll be storing, instead of storing it as an array like this, we'll be creating an object with the key of x, and in this case x is 5, so the key will be 5 and the value will be 10 like that. So we'll be storing this as this way. So if you call this function down here, if I call it with 5, it will first call this function and return 10. Then the second time I call it with 5, it will check, it will say it is there, so it will not call it again. So it will return the value that calling it. So the call count should be 1, just like it was before. So if I save this code and I run it, you can see, let's wait for it. You can see it will say 10, 10, and 1. So that means it worked. And if I call this, let me also duplicate, let me use another value so that you can see it works. So if I use something like, let me use 4, you can see I'm calling it with 5, then 4. So if I call it with 4, it will check if there is a key of 4, and it will not be there. So it has to call it. It will call now the function because 4 is not there. So if I run this code, this will return the result, and the call count will be 2, because for 4, there is no stored value for the key of 4. If I run this code, I think there's an error. Let me check. Console.log, my fun. Let me just save it and run it again. You can see it says 10, 10, 1. Then if I call it with 4, it will return 8, and you can see the call count is 2, meaning the function was called twice, because this 4 was not called with this argument before. And that is how memoization works. Now that you know about the pure functions, JSON.stringify and memoization, you can comfortably solve this challenge. So I have implemented these 3 functions here, the sum function, this one for Fibonacci, and this one for factorial. I've just written the implementation here. As they were described in the example, I've just written the implementation. Then down here, I've called them as in the example. Then you can see the actual function is here. I've not written anything inside it. I've just created this function called memoize that accepts another function fn as input, then returns a memoized function, but I've not written any implementation in it. So let us start now. And there's this variable here that keeps track of the count, like with the variable that you had in the previous example. I'm trying to mimic that example exactly. So yeah, so if you start to solve this challenge, you can see here in the initial challenge, you wrote just something like n to take one argument, but we don't know how many arguments this function can take. You can see this one takes 2, this one takes, this sum takes 2, this one fib takes 1. So to make our inside function flexible, we can use the rest parameters that we learned yesterday. So I can just use the rest parameters like that. That allows a function to take any number of arguments. So yeah, then I'll create my member variable here to store the cached values. I'll call it cache, like we had yesterday, like we had in the previous example. Then I'll use an object in this case, because I can't use an array because of this example here, this one. There's no index that has two items, like there's no index 2 and 3. It will be just one number. But this one, since it has a comma, the suitable data type is an object. So I'll use an object, and now for objects you must have a key. So before doing that, let me first implement this function. So this function takes fn, and I'm supposed to call fn with the arguments like that. But now I have to spread these arguments that, like we saw in the yesterday's example. This one is the spread operator. I'm spreading, you know that this rest parameters will convert these arguments to be an array. Then here I'm trying to spread this array into individual elements so that I can into a list, so that I can pass them into this other function. Then I can store this in a variable. I can store it in a variable. I'll say let result. I can store that result in a variable. Then I can return the results like that. So yeah, so this is how the function will be implemented. Then now I want to implement memoization. So I'll create a member variable here that I've created here. So since I'm using an object, I'll have to have a key. So I'll create a key. I'll say const key is equal. Since you have already seen how you can use JSON.stringify, I'll not explain it again. So JSON.stringify. Then I'll use this args as the key, like that. I'm using this args as the key. Let me just comment here, because we know that args is an array. So this one definitely will be an array. We have seen it many times that these rest parameters will be an array. So if you pass something like 2 and 3, it will be an array of 2 and 3. So I want this one to be the key. So it will be like this. Now this will be my key. I'm using this because you can call 2 and something like 4. That's why I'm just making it flexible. So I'll use that args as the actual key. So now that I have the key, before returning the results, I want to store the results in this cached variable. So I'll say something like cache. This is how you use this syntax, the square syntax, like that. You saw it already in the previous example, is equals to result, like that. Now every time this function is called, I'm storing the results into this cached variable. So if the same input is called, I don't want to call this function. So I'll create an if statement here. So I'll say if cached.key is present. So I'll say if cache has a key of key, if it is present, this one will be true. It will be a true value if it's there. If it's not, it will be a false value. So if it's true, I want to return it. So I'll say return cache index key, like that. So if it's true, return it. If it's not there, you can just call the function and store it, like the way we did before. Just the same thing. Then I can, if every time I call this function to increment that call count. So I'll increment call count here, like that. So this is the solution. You can just test it. Let me just go through it to see it is okay. So this memoized function takes a function. This memoized is a function that takes a function fn, and it calls args in that fn, and it first checks if that argument has been called before. If it has been called before, this key has to be up here. This key should be up here, because I have to access it. I have to declare it before I access it down here. So if I've called it, so I have to first use it as, I use this arg as my key first. Then I check if the key is there. If it's there, I return the value of that key. If it's not there, now run this function and increment the count, and also store the value in the cached variable, like that. So down here, I'm calling this sum. First, I'm using example 1. I'm using example 1 here. So I can, example 1, I'm using this sum function that I've declared here. Takes 2 parameters and returns the sum of those 2 parameters. So you can see here, I'm calling that sum and I'm assigning it to a variable example 1. You've already seen many times that you are treating a function as a first class citizen by assigning it to a variable Then if I can call example 1 as a function, then you can see I'm calling it 2 and 2. This one should return 4. Then if I call it the second time, it should return 4, but now it should get this value from the cached variable, not from calling the function. So that means if I call the call count, it should be 1, because the function will be called only this first time. This second time, the function won't be called. That's why the count will be 1. Then if I call this example 1 in different values, it should call the function, then the function will add 2 plus 1 to get 3. Then if I call count again, it will be 2, because the first time I called it here, then this is the second call of the function. So if I save this code and run it, I should get those expected results. So let me see. And you can see indeed those are the results that I expect. 44132, 44132. So yeah, example 1 is okay. So you can try example 2. So I'll just change this one to example 2 like that. Example 2. I've already declared it here. So example 2, I'm using the factorial. So let's go to example 2. So example 2, I'm supposed to call it with 2, 3. So example 2 takes, you can see, let's go to that function. This example 2, it's the factorial function. It takes only one argument and returns the factorial. So like 5 is something, factorial is something. If 5, factorial of 5 is 5. Factorial of 5 is 5 times 4 times 3 times 2 times 1. This is how factorial is being got. So here it's telling me to calculate the factorial of 2. So I'll just list this one to remain factorial of 2. Then 3. Then here 3. Then 2 again. So I'll duplicate this one to 2. Then change it to 2 again. Then call count. Then I'll get the count. I call it thrice. Then I get the count. Then call it again. Then get count. Then call it again with 3. Then get the count like that. So for the first time, factorial of 2, expect the results to be 2. Of 3, expect it to be 6. Of 2, it should be 2 again, but now this time it should not call the function, but should get the result from the cached data, because you have seen I've already called 2 before. So this one should not be calculated, it should be get from the cached data. So if I call the count should be 2, because the function was called here and here. This third time, the function was not called. You can see that's the expected result here. So factorial of 3 is 6. It should call the function. Then if you get the count, it should still be 2, because this factorial of 3 also was already calculated up here. So let me save this code and run it to see if those are the expected results. You can see 262, 262, and that is what we expect. So the third example, example 3. So I'll just duplicate this one to example 3. So I'll change all those to example 3. So example 3 is the Fibonacci series. So Fibonacci series, a Fibonacci is number like this. So Fibonacci starts with 0 and 1. Then to get the first Fibonacci number is 0 plus 1, you get 1. Then the second Fibonacci number is 1 plus 1, then you get 2. You take this actual number and plus the previous number. So the third, this is the first one, 1 plus 0, you get 1. This is the second one, 1 plus 1, you get 2. Then third one is 2 plus 1, you get 3. Then 3 plus 2, you get 5. 5 plus 3, 8. 8 plus 5, 13, and so on and so forth. That's how you get Fibonacci. So here, example 3, using the Fibonacci. Then you can see here, example 3, Fibonacci, you have to call it with 5. That's telling me to call it only once. So I'll just call it with 5. Then get the call count. So I'll just remove all this like that. So I'll get it with 5. So if I call it with 5, I should get 8. Then the call count should be just 1. So if I run this code, you can see it will give me 8 and 1. You can see 8 and 1. But if I call this 5 again. So if I copy this code and I call it down here again, it should give me 5, and the call count should also be still 1. So you can see it's still 8, 1, then it is still 8. So, but the call, if I also log this call count, I should log this call count again. It should be 1, because this second time it should not get it from there. You can see the call count is still 1. This second time it will not call the function, but it will get it from the cached data. And that is how memoization works. So that is it for this video. See you in the next video. Peace out.